Hello there, and welcome to The Weary Researcher, your quiet corner of the cosmos, where curiosity meets calm and wonder gently rocks you to sleep. I'm so glad you're here tonight, whether you're settling into bed, curling up on the couch, or simply trying to unwind after a long day. Before we begin our celestial journey, I'd love to know where in the world you're watching from, and what time it is right now in your little corner of the universe. Are you drifting off under city lights, nestled somewhere quiet and dark, or perhaps watching the actual night sky through your window? Drop a comment below if you'd like. It's always a joy to see this sleepy little community stretch across time zones and continents. If you enjoy these gentle explorations through science and space, I'd be ever so grateful if you gave this video a like and tapped that subscribe button. It helps more curious minds like yours find their way here, and it means I can keep making these soft starlit journeys for you. Now I should give you a gentle warning. While this video is designed to help you unwind and ease into rest, there's always the small risk that it might be just interesting enough to keep you listening. But if you do end up wide-eyed at 2 in the morning, thinking about orbital mechanics and tidal forces, well, at least you'll be a little wiser for it. Not such a bad trade, really. Tonight, we're going to drift into one of the most beautiful what-if scenarios in all of astronomy. We're going to imagine our pale blue dot adorned with something spectacular, something that would fundamentally change not just how our planet looks, but how life itself might have evolved. We're going to explore what would happen if Earth had rings. Picture this for a moment. You step outside on a clear evening, and stretching across the sky above you is a magnificent arc of light. Not the moon, not clouds, but a shimmering band of cosmic debris encircling our entire planet. Depending on where you live, this celestial jewellery might appear as a thin line rising straight up from the horizon, or perhaps as a glorious rainbow-like arch spanning from east to west. These aren't just pretty decorations floating in space. Earth's hypothetical rings would be a fundamental part of our planet's story, influencing everything from our climate and tides to the migration patterns of birds and the myths our ancestors told around campfires. They would be visible both day and night, never rising or setting, always hanging there in the exact same place in the sky, like a cosmic landmark that defines your view of the heavens. But here's what makes this more than just a flight of fancy. Earth may have actually had rings before, not recently, mind you, but hundreds of millions of years ago, long before the first fish wriggled through ancient seas. Scientists have found evidence suggesting that around 466 million years ago, our planet may have sported a Saturn-like ring system for tens of millions of years. The evidence is written in stone quite literally. There's a curious band of impact craters near the equator from that time period, all clustered in a way that suggests they came from debris falling from a ring system. The chances of these impact sites being created by random, unrelated asteroid strikes are about 1 in 25 million. That's compelling evidence that Earth once wore a crown of cosmic debris. So how would rings form around Earth today? The answer lies in something called the Roche limit, a boundary in space where tidal forces become stronger than gravity. For Earth, this invisible border sits about 19,900 kilometers from our planet's center. If any large object, say an asteroid or even our moon, were to drift inside this boundary, it would start to break apart, torn to pieces by Earth's gravitational embrace. The resulting debris wouldn't just float away into space, instead it would be captured by Earth's gravity and gradually migrate to form a ring around our planet's equator. This is likely what happened all those millions of years ago when an asteroid came too close and was shredded by tidal forces, its remains spreading out to form Earth's ancient ring system. Now, if Earth had rings today, they would be quite different from Saturn's magnificent ice rings. Earth sits much closer to the Sun, and that extra radiation would cause any ice in our rings to sublime away, turning directly from solid to gas without ever becoming liquid. Instead, our rings would likely be made of rock and dust, silicate materials similar to what you'd find on the Moon. But don't think that would make them any less spectacular. Even rocky rings would create breathtaking displays, especially when illuminated by sunlight during different times of day and seasons. The Moon, after all, reflects only about 12% of the light that falls on it. Yet it appears brilliantly bright in our night sky because it's close to us and receives so much sunlight. The appearance of Earth's rings would depend entirely on where you live. Near the equator, in places like Quito, Ecuador, you would see the rings edge on, appearing as a thin line stretching straight up from the horizon toward the zenith. It would be like looking at a cosmic blade cutting the sky in half. Travel north or south, and the perspective would change dramatically. In Washington, D.C., the rings might arc across the sky like an otherworldly rainbow, a bridge of light connecting east and west horizons. Near the Arctic Circle, they might appear as a glowing hump on the horizon, barely clearing the landscape, but still visible as a reminder of the cosmic architecture surrounding our world. These rings would create their own weather, in a sense. During winter in the southern hemisphere, they would cast shadows on that half of the world, potentially making winters colder and more severe. In summer, those same shadows would provide relief from the sun's heat, but the rings would also reflect sunlight back down to Earth, creating what scientists call ring shine, which might actually increase the total amount of light our planet receives. The seasonal effects would be particularly pronounced because Earth's tilted axis means that different hemispheres would experience varying degrees of ring shadowing throughout the year. The climate implications are complex and still being studied, but it's clear that rings would fundamentally alter Earth's energy balance. And then there's the matter of Earth's shadow falling on the rings themselves. Depending on the time of day, season, and your latitude, you might see our planet's shadow sweep across the ring system like the hand of a cosmic clock. During equinoxes, when the sun lies on the same plane as the rings, Earth's shadow would stretch across them to its greatest extent, plunging large portions into darkness. Around the edges of this shadow, you would see light filtered through Earth's atmosphere, creating what might be described as a blood-red rim along the shadow's boundary. It would be a daily reminder that we live on a sphere floating in space, watching our own world's silhouette painted across the sky. The rings wouldn't be uniform or unchanging. Like Saturn's rings, Earth's would likely show gaps and divisions, maintained by small shepherd moons that would orbit among the debris. These tiny moons, probably no larger than city blocks, would act like cosmic sheepdogs, using their gravitational influence to keep ring particles in line and create distinct bands and divisions. These shepherd moons would appear as moving points of light, trekking around Earth in predictable orbits like the hands of a vast celestial clock. Ancient navigators could have used them to determine longitude, watching their positions change as reliable markers of time and location. The rings themselves might show mysterious spokes, similar to those seen in Saturn's rings, rotating like the arms of a cosmic wheel and serving as additional time markers. But perhaps the most profound impact would be on life itself. Many animals rely on celestial navigation for migration, using the positions of stars and the moon to find their way across vast distances. Earth's rings would provide an additional, highly visible landmark that could be seen from anywhere on the planet. Birds, sea turtles, and countless other creatures might have evolved entirely different navigation systems, perhaps even more sophisticated than what we see today. The rings would also affect the growth of plants by altering the amount and timing of sunlight reaching Earth's surface. In areas frequently shadowed by the rings, vegetation might have evolved to be more efficient at photosynthesis, or ecosystems might have developed entirely different energy cycles based on the rhythm of ring shadows passing overhead. Human culture and mythology would be utterly transformed. The The rings would be impossible to ignore, dominating the sky and serving as a constant reminder of our planet's place in the cosmic order. Every human civilization would have stories about them, explanations for their origin, and calendars based on their shadows and the movement of their shepherd moons. At temperate latitudes, the ring's appearance as an arch might have symbolized a bridge between heaven and earth. Different cultures around the world would see them differently based on their latitude, potentially leading to conflicting mythologies and even wars over the correct interpretation of these celestial phenomena. The scientific revolution might have happened differently too. With such obvious evidence of celestial mechanics visible every night, humans might have developed sophisticated astronomy much earlier, or perhaps the rings would have been seen as so supernatural that they actually delayed scientific understanding. The constant presence of ring shadows might have led to the development of more accurate sundials and timekeeping devices centuries earlier than in our timeline. And speaking of time, the rings would serve as a giant cosmic timepiece. Earth's shadow moving across them would mark the hours, while the shepherd moons would tick by like the hands of an enormous clock face visible to everyone on the planet. This could have accelerated human understanding of orbital mechanics and led to earlier space exploration. But there would be challenges too. In our modern world, Earth's rings would complicate space travel significantly. Satellites would need to be carefully positioned to avoid collisions with ring particles. The International Space Station, orbiting about 400 kilometers above Earth's surface, would likely be below the rings and relatively safe. But geostationary satellites, which orbit much higher, might need to be repositioned or protected. Depending on the density and composition of the rings, they could interfere with radio communications, GPS signals, and other technologies we've come to depend on. Space agencies would need to develop new techniques for navigating through or around ring debris, and the night sky would be constantly filled with tiny meteors as ring particles occasionally fall to Earth and burn up in our atmosphere. The beauty, though, would be incomparable. Every sunset would be enhanced by light reflecting off the rings. Every dawn would see them illuminated like a cosmic necklace. On clear nights, the rings would glow softly in earthshine, and during eclipses they might remain faintly visible even when the sun is blocked. Children would grow up pointing at different parts of the ring system, learning their names the way we learn constellations. Lovers would meet under the light of the rings. Poets would find new metaphors in their eternal presence. The rings would be as much a part of human experience as the sun and moon, woven into the fabric of our daily lives. So as you drift off to sleep tonight, imagine looking up and seeing not just stars and the occasional planet, but a magnificent ring system arcing across the heavens. Picture the gentle glow of ring shine illuminating your face, the slow passage of shepherd moons marking the hours, and the peaceful knowledge that Earth wears a crown of cosmic beauty. The rings would remind us every single day that we live on a world that is both ordinary and extraordinary. Ordinary in that the same physical laws that create rings around Saturn could create them here. Extraordinary in that such beauty exists at all, whether around distant gas giants or potentially around our own pale blue dot. Now, that gentle arc of light across the sky might seem like pure fantasy, but the science behind it is as real as the ground beneath your feet. In our next journey together, we'll explore exactly how such rings would form, what they'd be made of, and why Earth's large moon makes permanent rings unlikely but not impossible. Until then, sleep well, dream of cosmic jewelry adorning our world, and remember that the universe is full of wonders we're only just beginning to understand. The night sky we see is beautiful, but it's just one possible version of what could be. Sometimes, the most profound discoveries come from asking a simple question. What if, sweet dreams, fellow traveller, and may your rest be as peaceful as moonlight filtered through rings of stardust. But what would these rings actually look like from down here on Earth? The answer, like so many things in astronomy, is beautifully complex. You see, the appearance of Earth's rings would depend entirely on where you happen to be standing on our planet's surface. If you lived near the equator, perhaps in Quito, Ecuador, or somewhere along the Amazon, the rings would appear as a thin, brilliant line stretching straight up from the horizon. Imagine looking east or west and seeing what looks like a luminous thread drawn across the sky with a cosmic ruler. The rings would rise vertically, bisecting the heavens like a celestial bridge connecting Earth to space, but travel north to Washington, D.C., or London, or any temperate latitude, and the rings would transform into something altogether more dramatic. Here they would arch across the sky like an impossible rainbow, a glowing span that never fades, never moves, and never quite seems real. During the day, they might shimmer faintly against the blue, like mother of pearl caught in sunlight. At night, they would dominate the darkness, a river of light flowing from horizon to horizon. Journey even farther north, perhaps to the edge of the Arctic Circle, and the rings would appear lower still, like a luminous hump resting on the horizon. They would seem almost close enough to touch, though of course they would still be thousands of miles above your head. These rings wouldn't be made of ice as Saturn's are. Earth sits too close to the sun for that. Our star's radiation would sublime any ice away before it could accumulate. Instead, Earth's rings would likely be composed of rock and dust, particles of silicon and stone that would still catch and scatter sunlight in beautiful ways. Think of how the moon glows in the night sky, even though moon rock reflects only about 12% of the light that hits it. The moon appears bright simply because there's so much light falling on it, and because it's relatively close to us. Earth's rings would work in much the same way, even if they were made of dark, rocky material. The sheer quantity of particles and their proximity to us would make them shine. During the day, they might appear as a pale, opalescent band. At night, they could glow with reflected Earthlight and sunlight, creating their own subtle illumination. But here's where things become truly fascinating. These rings wouldn't just hang there, static and unchanging. They would interact with Earth in ways both subtle and profound. As our planet rotated beneath them, shadows would dance across the ring system. During the equinoxes, when the sun lies in the same plane as the rings, Earth's shadow would stretch across them to its greatest extent, plunging vast sections into darkness. Around the edges of Earth's shadow on the rings, you would see something magical. Light filtered through our planet's atmosphere. The same atmospheric effects that give us red sunsets would paint the shadow's edges in brilliant colours. Imagine looking up to see a blood-red rim around Earth's shadow as it moved across the rings, like a cosmic eclipse happening above your head, and the rings themselves would change throughout the day and night. When the sun was behind them, they might appear dark and mysterious, visible mainly as a silhouette against the stars. When illuminated from the front, they would blaze with reflected light. The interplay of shadow and illumination would create an ever-changing display, a celestial light show that would make our current northern lights seem modest by comparison. If Earth had shepherd moons, small satellites that help maintain ring structure, like cosmic sheepdogs, these would add yet another layer of wonder. These moons would appear as bright pearls moving slowly along the ring's edges, taking days or weeks to complete their orbits. Ancient astronomers would have tracked their movements, using them as cosmic calendars and navigational aids. The rings would also affect how we experience seasons. During winter, in the northern hemisphere, the rings would cast their shadow on the southern hemisphere, and vice versa. This could make winters colder and more severe in both hemispheres, as the rings blocked some of the sun's warming rays. But at the same time, Ring shine, light reflected from the rings back down to Earth, might provide a gentle illumination during long winter nights. Imagine stepping outside on a clear winter evening and finding the snow-covered landscape bathed not just in moonlight, but in the soft, steady glow of Earth's rings overhead. The world would never be truly dark, even on the most overcast nights. Some of that ring-reflected light would filter through the clouds, creating a perpetual, gentle twilight. The ecological effects would be profound as well. Many animals navigate by celestial landmarks, and Earth's rings would provide the ultimate fixed reference point in the sky. Unlike the sun and moon, which rise and set, the rings would always be there, always in the same position relative to any point on Earth's surface. Migrating birds, sea turtles, and countless other creatures would likely evolve to use the rings as their primary compass, but perhaps most remarkably of all, these rings would never rise or set. They would be a permanent feature of our sky, as constant as the horizon itself. Unlike clouds that drift or the sun that travels from east to west, the rings would remain perfectly still overhead, a cosmic landmark that would define the sky from every location on Earth. From a scientific perspective, we know such rings are possible because Earth may have actually had them before. About 4.5 billion years ago, when our planet was young, a Mars-sized object called Theia collided with Earth in a cosmic impact of unimaginable violence. The debris from this collision formed a ring of matter in Earth's orbit, matter that eventually coalesced into the moon we see today. In a sense, our moon is what remains of Earth's ancient ring system, gravity having gathered the scattered pieces into a single, massive satellite. And remarkably, there's evidence that Earth had rings much more recently than that. Some scientists believe that around 466 million years ago, during the Ordovician period, Earth captured and destroyed a passing asteroid. The debris from this cosmic collision may have formed a ring system that lasted for tens of millions of years, possibly contributing to a period of global cooling and even an ice age. The evidence for this ancient ring lies in a peculiar pattern of impact craters from that time period. Instead of being randomly distributed around the globe, these craters cluster near the equator, exactly where debris from a ring system would be most likely to fall. The chances of this pattern occurring by random asteroid impacts are about 1 in 25 million. It seems our planet has worn rings before, like cosmic jewellery from a distant age. So as you settle in tonight, perhaps under a sky punctuated only by stars and the occasional passing cloud, imagine what it might be like to live beneath Earth's rings. Picture that glowing arch stretching across the heavens, those slowly moving shepherd moons, the interplay of shadow and light as our planet rotates beneath its celestial crown. It's a reminder that even our familiar Earth, this blue marble we call home, still holds mysteries and possibilities we're only beginning to understand. The sky above us, for all its apparent simplicity, is a canvas upon which the universe paints with gravity and light, time and motion. And who knows, perhaps somewhere out there, in the vast cosmic web of parallel possibilities, there's an Earth with rings, where people look up at a glowing arch of stone and starlight and wonder what it might be like to live on a planet with nothing but empty sky overhead. Part 3. The Architecture of Reality. How Rings Shape Time and Space. Now that we've explored the visual poetry of Earth's hypothetical rings and traced the scientific foundation for their existence, we arrive at perhaps the most profound question of all. How would these celestial bands fundamentally alter the very fabric of our reality? For rings around Earth would not merely be decorative additions to our sky. They would be massive gravitational structures containing trillions of tons of material, operating as cosmic clockwork that would reshape everything from our understanding of time to the evolution of life itself. To truly grasp this transformation, we must first understand that rings are not static decorations, but dynamic systems in constant motion. Each particle within Earth's rings would follow its own precise orbital path, governed by the same gravitational laws that keep our moon in its monthly dance around us. These countless fragments of rock and dust would circle our planet with clockwork precision, some completing their orbits in just a few hours, others taking days, all depending on their distance from Earth's surface. This celestial choreography would create something unprecedented in human experience, a visible, ever-present demonstration of gravitational mechanics playing out above our heads. Unlike our moon, which appears to move slowly across the sky over the course of hours, ring particles would stream past in flowing rivers of light and shadow. The outer edges might drift leisurely like distant clouds, while inner regions would race overhead with the urgency of shooting stars that never burn out. Such a dynamic system would fundamentally alter our relationship with time itself. Currently, we measure our days by the sun's passage, and our months by the moon's phases. But with rings overhead, we would gain an entirely new temporal framework. The streaming particles would create natural time markers visible to anyone who looked up. Shepherd moons embedded within the ring system would serve as cosmic hour hands, their predictable orbits offering a celestial chronometer far more precise than any sundial. Imagine navigators of antiquity, no longer dependent solely on star charts and seasonal changes. The rings would provide a constant reference frame, a cosmic GPS system written in stone and starlight. The way shadows moved across the ring system throughout the day would offer precise indicators of time, while the changing angles of ring illumination could serve as seasonal calendars. These natural chronometers would have accelerated human understanding of astronomy and mathematics by centuries, perhaps millennia, but the effects would extend far beyond mere timekeeping. The gravitational influence of such a massive ring system would create subtle but measurable changes in Earth's tidal patterns. While our moon would remain the primary driver of ocean tides, the rings would add complex harmonics to this ancient rhythm. Coastal regions might experience multiple daily tidal cycles, with the ring system's gravitational pull creating secondary peaks and valleys in the ocean's rise and fall. These altered tidal patterns would, in turn, reshape the very coastlines where early life emerged from the primordial seas. Tidal pools, those crucial laboratories where marine organisms first adapted to terrestrial existence, would follow more complex flooding and exposure cycles. The increased tidal complexity might have accelerated evolutionary processes, creating more diverse ecological niches and potentially speeding the transition from sea to land for early life forms. The rings would also serve as a massive filter for incoming cosmic radiation and meteorites. Earth's ring system would act as a natural shield, intercepting some of the smaller space debris that currently reaches our atmosphere as shooting stars. While this protective effect would be relatively minor compared to our atmosphere's natural shielding, it might nonetheless alter the frequency and distribution of meteor impacts over geological timescales. More dramatically, the rings would fundamentally change Earth's energy balance with space. The ring system would reflect a significant portion of incoming solar radiation back into space, potentially cooling the planet by several degrees. This albedo effect could trigger ice ages, or conversely, could moderate temperature swings between seasons. The exact climatic impact would depend on the ring's composition and density, but the effect would be global and permanent. During certain times of year, when Earth's axial tilt positioned the rings edge-on to the sun, they would cast enormous shadows across the planet's surface. These shadow seasons could last for weeks, creating temporary but dramatic climate zones where the usual patterns of day and night would be replaced by extended periods of dimmed sunlight. Such events would occur with astronomical precision, creating predictable but profound seasonal variations unlike anything we experience today. The biological implications of these shadow seasons would be extraordinary. Plant life would need to adapt to periodic reductions in available sunlight, possibly developing enhanced energy storage mechanisms or alternative photosynthetic strategies. Animal migration patterns would likely evolve around these shadow periods, with species timing their breeding cycles, hibernation, and food gathering to account for the ring's seasonal effects. Perhaps most remarkably, the rings would serve as a natural laboratory for understanding planetary formation and cosmic mechanics. Every day, researchers could observe gravitational resonances, orbital mechanics, and particle dynamics playing out overhead. The ring system would provide an unparalleled opportunity to study the same processes that shaped our solar system billions of years ago, but compressed into human observable timescales. The shepherd moons maintaining the ring structure would offer particularly valuable insights. These small bodies would demonstrate orbital mechanics in real time, their gravitational influence on surrounding ring particles creating visible waves and patterns that would ripple through the system like cosmic pond ripples. Scientists could observe how these moons carve gaps in the rings, how they shepherd particles into neat formations, and how they interact with each other in their complex orbital dance. Such direct observation of gravitational mechanics would have revolutionized physics centuries earlier than actually occurred. Newton's laws of motion and universal gravitation might have been discovered in ancient times, simply by watching the predictable behavior of ring particles and shepherd moons. The mathematical principles governing orbital mechanics would be written large across the sky, visible to any civilization that developed sufficient observational skills. The rings would also create unique atmospheric phenomena unknown on our current Earth. As ring particles occasionally fell from their orbits, they would create spectacular meteor showers far more frequent and predictable than those we see today. These cosmic fireworks would follow the ring system's geometry, creating radial patterns across the sky as debris burned up in our atmosphere. Some of these falling particles might be large enough to survive atmospheric entry, creating a steady rain of meteorites with compositions reflecting the ring system's makeup. These space-delivered materials could become valuable resources for developing civilizations, providing rare metals and minerals that would otherwise remain locked deep within Earth's crust. The electromagnetic environment around Earth would also be altered by the ring system. The countless particles orbiting our planet would interact with Earth's magnetic field in complex ways, potentially creating unique aurora displays and radio phenomena. The rings might even develop their own electromagnetic signature, generating radio emissions that could be detected and studied by sufficiently advanced technology. All of these effects would compound over geological timescales. The gradual evolution of the ring system, as particles collided, merged, and were occasionally scattered by gravitational perturbations, would create a constantly changing cosmic environment. Civilizations might rise and fall, watching different configurations of the same basic ring system, each era defined by the particular arrangement of gaps, concentrations, and shepherd moons overhead. The psychological and cultural impact of such a dynamic, ever-present celestial feature cannot be overstated. Unlike our current sky, which changes slowly and subtly over the course of seasons and years, a ringed Earth would offer constant, visible reminders of cosmic forces at work. The streaming particles, the interplay of light and shadow, the precise mechanics of orbital motion, all would be woven into the daily experience of every human who ever lived. This constant celestial presence would likely accelerate the development of scientific thinking and mathematical understanding. When the fundamental forces governing the universe are visible overhead every day, the leap from observation to theoretical understanding becomes much shorter. The scientific revolution might have occurred in ancient Babylon or classical Greece, simply because the evidence for cosmic order would be impossible to ignore. Yet for all these grand implications, perhaps the most profound effect would be the simplest: beauty. Earth's rings would add a dimension of visual splendor to our world that would touch every human life. Every sunset would paint the rings in brilliant colors. Every clear night would reveal their ghostly glow beneath the stars. Every dawn would bring new patterns of light and shadow streaming across the sky. And in quiet moments, when the day's work was done, and the evening sky darkened to reveal the full glory of our planet's cosmic jewelry, we might pause to consider our place in this vast, beautiful, mechanically precise universe. The rings would serve as a constant reminder that we live not on an isolated world, but as part of a grand celestial system, governed by forces both powerful enough to move worlds and gentle enough to craft beauty from simple stone and starlight. In the end, Earth's rings would represent far more than an astronomical curiosity or a planetary ornament. They would be a bridge between the cosmic and the terrestrial, between the mathematical and the mystical, between the forces that shape worlds and the consciousness that contemplates them. They would remind us twice daily and without fail that we are citizens, not just of Earth, but of the cosmos itself. Now that we've journeyed through the cosmic dance of gravity and celestial mechanics, let's explore something closer to home yet equally mesmerizing: the geological forces that shape our planet. Imagine for a moment that you could press pause on Earth's constant motion, step back and observe our world as a living, breathing sculpture. Mountains rise and fall, continents drift like massive rafts, and deep beneath our feet, molten rock churns in patterns as ancient as time itself. We've seen how the moon tugs at our oceans, creating the rhythmic pulse of tides. But there's another force at work, one that operates on timescales so vast they dwarf human experience, yet shapes every landscape we know. This is the story of plate tectonics, the slow-motion dance of Earth's outer shell that has been choreographing our planet's surface for billions of years. Picture Earth not as a solid sphere, but as a layered onion. At the very centre lies a scorching hot iron core, surrounded by a mantle of semi-molten rock that flows like thick honey heated over cosmic fires. Above this churning interior sits the lithosphere, a relatively thin shell of cooler, more rigid rock that we call home. But here's where it gets fascinating. This shell isn't one continuous piece. It's broken into enormous puzzle pieces called tectonic plates, and these plates are constantly moving. The movement is imperceptibly slow by human standards, just a few centimetres per year, about the same rate your fingernails grow. But given enough time, this gentle crawling becomes a powerful sculptural force. Plates collide and one dives beneath another in a process called subduction, creating deep ocean trenches and volcanic mountain ranges. They pull apart at mid-ocean ridges, allowing new seafloor to emerge like a slow-motion conveyor belt, and sometimes they simply slide past each other, grinding and catching until the built-up tension releases in sudden earth-shaking jolts. This grand geological ballet has been performing for over 4 billion years, reshaping continents, raising mountains, and opening ocean basins. The Himalayas exist because India, once an island continent, crashed into Asia with the inexorable force of deep time. The Atlantic Ocean grows wider each year as Europe and North America drift apart, while the Pacific shrinks as its edges are consumed by the hungry mouths of subduction zones. What's truly remarkable is that we're witnessing this process right now, in real time. Every earthquake is a reminder that the ground beneath our feet is not as stable as it seems. Every volcanic eruption is the Earth's interior making a dramatic appearance at the surface. Every hot spring and geyser is a gentle exhale from the deep furnace below. Scientists have only understood plate tectonics for about 50 years, making it one of the youngest major theories in geology. Before this revelation, the idea that continents could move was considered absurd. Now we know that our planet's surface is in constant, restless motion, driven by the slow circulation of heat from Earth's molten interior. It's a reminder that even the most solid-seeming things in our world are, on geological timescales, as fluid as water. This understanding has revolutionized how we see Earth's history. We can now trace the paths of ancient continents, understand why similar fossils appear on opposite sides of oceans, and predict where earthquakes and volcanoes are most likely to occur. We've learned that our planet is not a static stage for life, but an active participant in the story, constantly creating new environments and challenges that have driven the evolution of species, including our own. As you drift towards sleep tonight, perhaps you can imagine the vast, patient forces at work beneath you. Somewhere deep below, rock flows like a slow river, continents inch across the globe, mountains grow grain by grain, and in this endless geological conversation between Earth's interior and surface, our planet continues to write its autobiography in stone, one microscopic movement at a time. The dance continues as it has for billions of years, as it will for billions more. And we, for this brief moment in Earth's long story, get to be conscious witnesses to this magnificent, slow-motion transformation of our world. But what would it actually be like to live on a ringed Earth? We've explored the physics, the formation, the spectacular views. But now comes perhaps the most fascinating question of all. How would rings fundamentally reshape life itself? Because make no mistake, rings wouldn't just be a pretty addition to our sky. They would be a game changer of astronomical proportions, literally rewriting the story of life on our planet. Let's start with the most immediate and dramatic impact, the dance of light and shadow. Earth's rings would create a moving pattern of shade across our planet's surface, following the tilt of our axis through the seasons. During winter in the northern hemisphere, the rings would cast their shadows primarily across the north, while summer would see those same shadows sweep across the southern regions. This isn't just a gentle dimming of sunlight, we're talking about significant reductions in solar radiation reaching the ground. Imagine, if you will, vast swaths of land plunged into what scientists call ring shadow for months at a time. Temperatures in these shadowed regions could drop dramatically, potentially by 10 to 20 degrees Celsius or more. We're not talking about a gentle cooling effect here. This could create entirely new climate zones, bands of perpetual twilight that would make our current polar regions seem balmy by comparison. But here's where it gets really interesting from an evolutionary perspective. Life as we know it is remarkably adaptable. On a ringed Earth, evolution would have had billions of years to work with these shadow patterns. The result? We might see entirely different ecosystems than the ones we know today. Plants in ring shadow zones might evolve to be incredibly efficient at capturing the faint, filtered light that manages to slip through the ring debris. Perhaps they'd develop massive leaf surfaces or entirely new photosynthetic pathways that could work with dramatically reduced sunlight. Animals, too, would tell a completely different story. Migration patterns would be governed not just by seasonal temperature changes, but by the predictable advance and retreat of ring shadows across the landscape. Entire species might have evolved to follow these shadow zones, much like some animals today follow the seasons. Others might have adapted to thrive in the perpetual twilight, developing enhanced night vision or entirely different sensory systems. The seasonal effects would be unlike anything we experience today. While our Earth has relatively mild seasonal variations for most of the planet, a ringed Earth would have extreme seasonal contrasts, Areas that bask in full sunlight during one part of the year might be plunged into frigid, shadowy conditions just months later. This would create what we might call super seasons, periods of dramatic environmental change that would make our current winter to summer transitions seem gentle by comparison. Ocean currents would be fundamentally different too. The uneven heating caused by ring shadows would create entirely new patterns of water circulation. We might see vast oceanic dead zones in perpetually shadowed areas, while other regions experience intense heating and convection. Hurricane and storm patterns would follow completely different rules, potentially creating weather systems that would be utterly alien to us. But let's zoom in on something even more personal. What about human civilization? If humans had evolved on a ringed Earth, our entire understanding of astronomy, navigation, and timekeeping would be radically different. The rings would serve as a massive celestial clock, with features moving across them providing precise timekeeping capabilities that would make our current atomic clocks seem almost primitive. Ancient civilizations would have developed around ring watching. Imagine the pyramids and stone circles, but designed to track the subtle movements of ring features across the sky. Navigation would be revolutionized. Instead of using stars which require clear weather and can be obscured by clouds, navigators could use the rings themselves, visible even through light cloud cover, as an incredibly precise compass and clock system. The cultural implications are staggering. Every human mythology, every religion, every philosophical system would be built around the presence of these magnificent rings. They would be the ultimate symbol of the divine, the cosmic, the eternal. They never rise or set, never change position in the sky, yet they're always subtly shifting, always displaying new patterns of light and shadow. They would be humanity's most constant companion and most mysterious teacher. Consider the psychological effects. Growing up under ringed skies would fundamentally alter human consciousness. The rings would provide a constant reminder of our planet's place in the cosmic order, a visible demonstration that we live on a world that is itself part of something larger and more complex. There would be no looking up at the sky and forgetting about space. Space would be right there, arcing across the heavens every single day. Agriculture would tell an entirely different story. Farmers would need to understand not just seasonal weather patterns, but the intricate dance of ring shadows across their fields. Crop rotation would be planned around shadow cycles. Some crops might be specifically adapted to grow in ring shadow conditions, while others would be timed to take advantage of the brief periods of full sunlight. Cities would be planned differently too. Architecture would need to account for the predictable shadow patterns. Buildings might be designed with adjustable features to maximize light during shadowed periods or to provide cooling during times of intense, unfiltered sunlight. Urban planning would become a complex three-dimensional puzzle, with city layouts optimized for the ring shadow cycles. The economic implications would be enormous. Entire industries would be built around predicting and preparing for ring shadow effects. Energy production would need to be far more sophisticated. Solar power would be highly variable, requiring massive energy storage systems or alternative power sources for shadowed periods. Transportation would need to account for the dramatic temperature variations between shadowed and unshadowed regions. But perhaps most fascinating of all is how this would affect human biology itself. Our circadian rhythms, our sleep cycles, our entire internal biological clock is currently synchronized to a 24-hour day-night cycle. On a ringed Earth, we'd have additional cycles to contend with. The subtle changes in light quality as it filters through different parts of the ring system, the gradual shifts in ring shadow patterns throughout the year. Humans might have evolved entirely different sleep patterns, perhaps with multiple rest periods throughout the day, corresponding to different types of ring-filtered light. Our eyes might be adapted to see in much lower light conditions or to detect subtle differences in the quality of ring-filtered sunlight that would be invisible to us today. The implications for space exploration would be profound too. Growing up on a world with visible cosmic structures would likely make humans much more space-oriented from the beginning. Instead of seeing space as this distant, unreachable realm, it would be right there above us, part of our daily experience. Space programs might have developed much earlier and more aggressively, driven by humanity's intimate familiarity with orbital mechanics displayed right above their heads every day. But there's a darker side to consider as well. The ring shadows could create significant challenges for food production. Extended periods of reduced sunlight could lead to crop failures, famines, and mass migrations. Wars might be fought over access to unshadowed land. Climate refugees could become a constant reality as ring shadow patterns shift with the seasons. Disease patterns would be different too. With such dramatic seasonal variations in temperature and light, we might see entirely different patterns of seasonal illness. Some diseases might be adapted to thrive in the cold, shadowy conditions, while others might flourish in the intense heat of unshadowed summers. Yet for all these challenges, there's something profoundly beautiful about imagining human civilization developing under ringed skies. Every sunset would be transformed into a cosmic light show as the sun sets through the ring plane. Every dawn would bring new patterns of light and shadow dancing across the landscape. The night sky would never be truly dark. Ring shine would provide a gentle, constant illumination, perhaps reducing our reliance on artificial lighting. Children would grow up pointing not just to birds and clouds, but to the shepherding moons, visible as bright points moving along the ring edges. Poets would write not just about stars and moon, but about the eternal dance of ring and shadow. Artists would have an entirely new palette of cosmic inspiration to draw from. The philosophical implications are equally profound. Living under rings would provide a constant, visible reminder of orbital mechanics, of gravitational forces, of the deep physics that governs our universe. Humanity might have developed a much more intuitive understanding of these forces much earlier in our history. Our mathematics, our physics, our entire scientific worldview would be shaped by this daily experience of cosmic mechanics in action. In the end, a ringed Earth wouldn't just be Earth with some pretty decorations in the sky. It would be a fundamentally different world, with different life, different weather, different civilizations, and different possibilities. It would be a world where the cosmic and the terrestrial are intimately connected, where every day brings a reminder that we are part of something vast and beautiful and endlessly complex. And perhaps, in some alternate universe, that's exactly what happened. Perhaps there's a version of Earth where our ancestors looked up at magnificent rings arcing across the sky and built their entire civilization around the rhythm of light and shadow, the dance of ring and season. Perhaps they developed technologies we can't imagine, philosophies we've never conceived, and a relationship with the cosmos that we, with our bare sky, can only dream of. The rings would be more than just a feature of the landscape. They would be the conductor of life's symphony, the cosmic clockwork that sets the rhythm for everything from the migration of birds to the rise and fall of civilizations. They would be Earth's crown jewel, its most magnificent feature and its most profound teacher. Now let's explore how these cosmic companions would fundamentally alter one of humanity's most ambitious endeavors. Space exploration. Imagine looking up at the night sky and seeing not just stars and the moon, but a glittering highway of debris stretching across the heavens. Beautiful, absolutely, but for anyone dreaming of launching rockets or deploying satellites, Earth's rings would present both extraordinary challenges and unexpected opportunities that would reshape our entire approach to reaching the cosmos. The most immediate challenge would be navigation. Picture trying to thread a needle while wearing mittens, except the needle is moving. The thread is a multi-ton spacecraft, and a mistake could mean collision with countless chunks of rock and ice travelling at orbital velocities. Mission planners would need to map safe corridors through the ring system, identifying gaps and calculating launch windows with unprecedented precision. The International Space Station, currently orbiting at about 400 kilometers above Earth, might actually sit safely below the densest part of the rings, but geostationary satellites, those workhorses of modern communication, orbiting at 35 hours, 186 kilometers, would find themselves navigating through a cosmic obstacle course. Engineers would need to develop new technologies, perhaps spacecraft with enhanced shielding, or satellites designed to operate in the relatively clear zones between ring particles. Yet these challenges would spark remarkable innovations. We might have developed sophisticated debris tracking systems centuries earlier, perfecting our ability to monitor and predict the movement of countless objects in space. Navigation technology would be far more advanced, as precision wouldn't just be desirable, it would be absolutely essential for survival. The rings would also serve as a natural laboratory right on our doorstep. Instead of travelling to Saturn to study ring dynamics, we'd have our own cosmic laboratory overhead. Scientists could deploy probes directly into the rings, studying particle interactions, gravitational effects, and the delicate dance of shepherd moons. This proximity to ring phenomena might have accelerated our understanding of planetary formation and celestial mechanics by centuries. But perhaps most intriguingly, the rings could become humanity's first space-based resource depot. Those countless chunks of rock and ice wouldn't just be obstacles, they'd be building materials floating conveniently in orbit. Future space missions might harvest ring particles for radiation shielding, extract water ice for fuel production, or even use larger fragments as foundations for orbital habitats. Launch strategies would evolve dramatically. Rather than the direct, straight-shot trajectories we use today, spacecraft might follow spiraling paths, using the gravitational influence of ring particles to assist their journeys. We might develop specialized ring hopper vehicles designed to move efficiently through the debris field, collecting resources or conducting research. The psychological impact on space exploration would be profound too. Instead of venturing into the vast emptiness of space, astronauts would travel through a dynamic, ever-changing environment filled with natural landmarks. Navigation wouldn't rely solely on distant stars but could use prominent ring features as reference points. That massive ice boulder, this distinctive gap in the particle stream. Communication satellites would need creative solutions, perhaps networks of smaller, more maneuverable satellites that could adjust their positions to maintain clear signal paths through the rings. Or maybe we'd develop communication relays that use the rings themselves, bouncing signals off larger particles or using the conductive properties of ionized ring material. The rings would also create new forms of space weather. As particles collided and fragmented, they generate clouds of smaller debris that could affect spacecraft operations. Mission planners would need to track not just the major ring structures, but also these ephemeral debris clouds, adding another layer of complexity to space operations. Yet for all these challenges, the rings would make space feel less remote, less alien. They'd be a constant reminder that we live in a dynamic, interconnected cosmic system. Children growing up under ringed skies might feel a more intimate connection to space, seeing it not as a distant frontier, but as an extension of their world. Emergency procedures would be revolutionized too. Spacecraft in distress might find refuge among larger ring particles, using them as temporary shelters or sources of materials for repairs. The rings could serve as waypoints for rescue missions, providing reference points in the vast expanse of near-Earth space. Looking further ahead, the rings might become the foundation of humanity's first true space civilization. Permanent settlements could be built within stable ring gaps, taking advantage of the abundant materials and unique microgravity environment. These ring colonies might serve as stepping stones to the outer planets, training grounds where humans learn to live and work in space before venturing to Mars or the moons of Jupiter. The very presence of rings would remind us that space isn't empty. It's full of structure, beauty, and possibility. Every mission would be an adventure, through a landscape that changes with the seasons, as Earth's tilt shifts our perspective on the ring plane. Sometimes we'd launch through the rings' edge-on view, when they appear as a thin line across the sky. Other times, we'd navigate through their full, magnificent display. So while Earth's rings would certainly complicate our journey to the stars, they'd also enrich it immeasurably. They'd force us to become better engineers, more careful planners, and more resourceful explorers. And perhaps most importantly, they'd ensure that space exploration feels not like an escape from Earth, but like an extension of our beautiful, ringed world, a natural progression outward from our cosmic home, guided by the same forces that put those glittering bands in our sky in the first place. The atmosphere has its own memory, written in ice and stone, in the layers of sediment that carpet ocean floors, and in the ancient air bubbles trapped within glacial cores. These archives tell us that Earth's climate has never been perfectly still, never completely unchanging. But the story they're telling now is different from anything we've seen before. The plot is accelerating, the characters are changing, and we humans have become not just observers, but authors of this unfolding tale. To understand how Earth's rings might affect our planet's climate, we need to appreciate the delicate dance between sunlight, shadow, and the vast systems that regulate our world's temperature. Rings around Earth wouldn't simply be a beautiful backdrop to our skies. They would fundamentally alter the amount and distribution of solar energy reaching our planet's surface, potentially triggering climate changes that would ripple through every ecosystem, every ocean current, and every weather pattern we know. Picture the rings as a vast, shimmering curtain stretched across the equatorial sky. Unlike Saturn's rings, which are made primarily of ice and reflect sunlight brilliantly, Earth's rings would likely be composed of rocky material, similar to the debris found in our asteroid belt. This difference in composition would affect how much sunlight the rings absorb versus reflect, but even rocky rings would create significant shadows. The shadow cast by Earth's rings wouldn't be uniform or constant. As our planet rotates on its tilted axis, different regions would experience varying degrees of ring shadow throughout the day and across the seasons. During summer in the northern hemisphere, when that part of Earth is tilted toward the sun, the ring shadows would fall primarily across the southern hemisphere. 6 months later, as Earth continued its orbit, the situation would reverse, with ring shadows cooling the northern hemisphere during its winter months. This seasonal shadow dance would intensify the contrast between summer and winter in ways we can barely imagine. The hemisphere experiencing winter would not only receive less direct sunlight due to Earth's natural tilt, but would also be shrouded beneath the ring's shadow. Temperatures in these shadowed regions could plummet far below what we currently experience, potentially triggering the expansion of ice sheets and the formation of glaciers in regions that are currently temperate. But the effects wouldn't stop at temperature. The rings would also influence Earth's complex system of atmospheric circulation. Our planet's weather patterns are driven by the uneven heating of its surface. As warm air rises from heated regions and cooler air flows in to replace it. By blocking sunlight from reaching certain areas while allowing it to warm others, the rings would create new patterns of atmospheric heating and cooling potentially altering the paths of jet streams, the formation of storm systems, and the distribution of rainfall across the globe. Consider the monsoons, those seasonal wind reversals that bring life-giving rains to billions of people across Asia and Africa. These systems depend on the contrast between the heating of large land masses and the relatively stable temperatures of nearby oceans. Ring shadows could disrupt these temperature differences, potentially weakening monsoon systems and leaving vast agricultural regions without their expected rainfall. The consequences would be felt not just in reduced crop yields, but in the entire web of life that depends on these seasonal rains. Ocean currents, too, would feel the influence of Earth's rings. The great conveyor belt of global circulation that transports heat from the tropics toward the poles is driven by differences in water temperature and salinity. Ring shadows could cool certain ocean regions while leaving others exposed to full sunlight, altering the density patterns that drive these currents. Changes in ocean circulation could, in turn, affect the distribution of marine nutrients, the migration patterns of fish, and the regulation of global climate. The rings might also influence the formation and behaviour of clouds. Clouds form when warm, moist air rises and cools, causing water vapour to condense into droplets. By creating cooler regions beneath their shadows, the rings could suppress cloud formation in some areas while encouraging it in others. Since clouds themselves reflect sunlight back to space, changes in cloud patterns would create feedback loops, either amplifying or moderating the cooling effects of the ring shadows. But there's another side to this story. While the rings would block some sunlight, they would also reflect light back toward Earth, a phenomenon astronomers call ring shine. During certain times of the day and year, when the angle of the sun and the position of the rings align just right, this reflected light could actually increase the amount of illumination reaching Earth's surface. The interplay between ring shadows and ring shine would create a complex pattern of heating and cooling that would vary with location, season, and time of day. The equatorial regions, directly beneath the rings, would experience the most dramatic effects. These areas, which currently receive the most intense solar radiation and drive much of Earth's weather systems, would find themselves partially shaded for much of the year. The reduction in solar heating could weaken the convective processes that create tropical thunderstorms and drive the circulation patterns that distribute heat and moisture around the globe. This cooling of the tropics could have cascading effects on global climate. The tropical oceans are currently a major source of water vapour for the atmosphere, and this moisture helps trap heat through the greenhouse effect. Cooler tropical seas might evaporate less water, reducing atmospheric humidity and potentially leading to further cooling, a positive feedback loop that could drive the climate toward a significantly different state. The rings would also affect the amount of solar energy absorbed by Earth's ice sheets and glaciers. These frozen regions currently reflect most of the sunlight that hits them, helping to keep them cool and stable. But if ring shadows reduce the amount of sunlight reaching these areas, it could create conditions that allow ice to expand into regions that are currently ice-free. As more of Earth's surface became covered in reflective ice, even more sunlight would be reflected back to space, accelerating the cooling process. Scientists studying Earth's climate history have found evidence that our planet has experienced dramatic climate shifts in the past, often triggered by relatively small changes in the amount or distribution of solar energy reaching the surface. The presence of rings could create changes far larger than those that have driven ice ages or periods of dramatic warming in Earth's past. Yet Earth's climate system is remarkably resilient and complex. The same processes that could amplify the cooling effects of ring shadows might also work to moderate them. As some regions cooled, others might warm more than usual, and the atmosphere would work to redistribute this heat. ocean currents might shift to compensate for changes in heating patterns, and life itself would adapt, as it has countless times before, to new conditions. The rings would also interact with Earth's existing climate cycles in fascinating ways. El Niño and La Niña, the periodic warming and cooling of tropical Pacific waters that influence weather patterns around the globe, might behave differently under the influence of ring shadows. The seasonal movements of the intertropical convergence zone, the belt of thunderstorms that circles the globe near the equator, could shift in response to changes in solar heating patterns. Perhaps most intriguingly, the rings might create entirely new climate phenomena. The complex interplay of shadows, reflected light, and altered atmospheric circulation could generate weather patterns unlike anything we see on Earth today. We might witness the formation of persistent high-pressure systems beneath the densest parts of the rings, or the development of new types of storm systems along the boundaries between shadowed and sunlit regions. The timing of ring formation would also matter enormously. If rings appeared suddenly, perhaps from the breakup of a large asteroid or moon, the climate effects would be immediate and dramatic. Ecosystems would have little time to adapt, and the changes could trigger mass extinctions. But if rings formed gradually, over thousands or millions of years, life might have time to evolve and adapt to the changing conditions. From a human perspective, rings around Earth would present both challenges and opportunities. The cooling effects might make some currently warm regions more habitable, while rendering others too cold for agriculture or comfortable living. The altered patterns of rainfall could turn deserts into gardens or fertile plains into wastelands. Humanity would need to adapt its agricultural practices, migration patterns, and energy systems to cope with a fundamentally different climate. Yet there might also be benefits. The rings could provide natural climate regulation, helping to prevent overheating as greenhouse gas concentrations increase. The periodic shading might create natural cycles of cooling that could help stabilize Earth's temperature, and the beauty of ringed skies might inspire new forms of art, literature, and spiritual practice, enriching human culture in ways we can hardly imagine. As we consider the possibility of Earth having rings, we're reminded of how intimately connected all parts of our planet's system truly are. The atmosphere, oceans, ice, land, and life are not separate entities but parts of a single, integrated whole. A change to any one component, whether it's the addition of rings or the increase in greenhouse gases, ripples through the entire system in ways that can be difficult to predict but impossible to ignore. The rings would also serve as a constant reminder of our planet's place in the larger cosmos. Every day, as shadows swept across the landscape and ring shine illuminated the night sky, we would be reminded that Earth is not an isolated world, but part of a vast, dynamic universe. The rings would be a bridge between the terrestrial and the celestial, a daily reminder that the forces shaping our world extend far beyond our atmosphere. In studying how rings might affect Earth's climate, we gain a deeper appreciation for the delicate balance that currently sustains life on our planet. We see how small changes can have large consequences, how systems that seem stable can shift dramatically, and how the story of Earth's climate is still being written. Whether or not our planet ever acquires rings, understanding their potential effects helps us better appreciate the remarkable world we currently inhabit and the responsibility we bear for its future. The climate effects of Earth's rings would unfold over timescales, both human and geological, creating new rhythms in the great symphony of our planet's systems. Some changes would be immediate, visible within seasons or years. Others would take centuries or millennia to fully manifest, as ice sheets grew or shrank, as ocean currents found new paths, and as life adapted to new patterns of light and shadow. In this way, the rings would become part of Earth's story, adding new chapters to the ongoing tale of a planet in constant, beautiful motion. Looking at Earth's hypothetical rings, we come to a fascinating question. How would this cosmic crown above our heads affect the way we explore beyond our planet? The presence of rings would fundamentally alter humanity's relationship with space, creating both extraordinary opportunities and formidable challenges that would reshape our entire approach to leaving Earth's gravitational embrace. First, let's consider the orbital mechanics nightmare that rings would create. Currently, we launch spacecraft into carefully calculated trajectories, threading the needle through a relatively clear expanse of space. But with a ring system extending potentially tens of thousands of kilometers above Earth's surface, every launch would become an intricate dance around countless particles of rock and dust. Mission planners would need to map safe corridors through the rings, identifying gaps and stable zones where spacecraft could pass without catastrophic collisions. The debris field would operate on multiple scales. Larger chunks, perhaps the size of boulders or small buildings, would be trackable and avoidable with careful planning. But the real danger would come from the countless smaller particles, each one capable of punching holes through spacecraft hulls at orbital velocities. Even a pebble-sized fragment could be devastating when moving at tens of thousands of kilometers per hour. This would necessitate entirely new approaches to spacecraft design, with enhanced shielding, redundant systems, and perhaps even self-repairing materials. Navigation systems would require revolutionary advances. Our current GPS constellation orbits well above where Earth's rings would likely exist, but the ring particles would interfere with radio signals, creating dead zones and navigation shadows. New satellite networks would need to be established, possibly using a combination of high-altitude platforms above the rings and ground-based systems that could penetrate the particle field. The familiar practice of using Earth's horizon for navigation reference would become complicated, as the ring plane would create a false horizon that could confuse both human pilots and automated systems. The International Space Station, currently orbiting at about 400 kilometers altitude, would likely sit below the main ring structure, but getting there would be far more complex. Launch windows would be dictated not just by orbital mechanics, but by the constantly shifting density patterns within the rings. Certain times of day or year might offer clearer paths, while others would be virtually impassable. This could mean that emergency resupply missions or crew evacuations might face significant delays, fundamentally changing how we approach space station operations and safety protocols. Interestingly, the rings might also provide unexpected opportunities. The material composing the rings could serve as a vast source of raw materials for space construction projects. Instead of hauling everything up from Earth's surface at enormous cost, future space missions might harvest ring material for building space stations, solar arrays, or even spacecraft. This could transform space economics, making large-scale construction projects feasible in ways we can barely imagine today. The rings would also create unique scientific opportunities. Each particle would be a sample from Earth's ancient past, potentially offering insights into our planet's formation and early history. Robotic missions might specifically target ring material for analysis, turning the obstacle into a treasure trove of scientific data. The ring system itself would become a natural laboratory for studying gravitational dynamics, particle interactions, and the behavior of debris fields over time. Communication with spacecraft would face new challenges. Radio signals would scatter and attenuate as they pass through the particle field, creating communication shadows and requiring more powerful transmitters or alternative communication methods. Laser communication systems might become preferred for their ability to maintain coherent beams through the debris, though even these would need to account for particle interference. The psychological impact on astronauts would be profound. Instead of looking down at a clear view of Earth, they would see our planet framed by magnificent arcs of light and shadow. The rings would provide a constant reminder of home, visible from vast distances as a unique signature that no other planet in our solar system could match. This might provide comfort to long-duration missions, but it could also create a sense of being forever tethered to Earth, even when venturing to other worlds. Launch trajectories would need to be fundamentally reconsidered. The current practice of launching eastward to take advantage of Earth's rotation might need modification if the ring plane created obstacles in that direction. We might need to develop new launch techniques, perhaps using multiple burn sequences to thread through gaps in the rings, or even launching at steep angles to quickly clear the ring plane before adjusting course. Space debris management would become infinitely more complex. Our current concerns about space junk pale in comparison to managing a natural debris field. Any mission that added to the ring material through accidents or intentional disposal would have long-lasting consequences, potentially affecting future missions for centuries. International cooperation on space traffic management would become not just advisable, but absolutely essential. The rings might also affect Earth's magnetic field interactions in ways that could impact spacecraft electronics. Charged particles trapped in the ring system could create additional radiation hazards, requiring enhanced shielding for both equipment and human crews. Solar panel efficiency might be reduced in certain orbital positions due to shadowing effects from ring material. Perhaps most intriguingly, the presence of rings might accelerate the development of new propulsion technologies. Chemical rockets, with their limited fuel capacity and single-use nature, might prove inadequate for the complex maneuvering required to navigate ring systems safely. This could drive innovation in electric propulsion, nuclear thermal systems, or even exotic concepts like magnetic plasma sails that could interact with the ring environment itself. The visual impact alone would transform space exploration from a scientific endeavour into something approaching art. Every spacecraft image would be framed by the graceful curves of the rings. Earth would never again look like the simple blue marble of Apollo photographs, but rather like a jewelled ornament suspended in cosmic architecture. This aesthetic transformation might capture public imagination in ways that drive increased support for space exploration. Long-term space missions would need to account for ring evolution. Unlike the relatively stable environments we currently navigate, rings are dynamic systems that change over time due to gravitational perturbations, collisions, and orbital decay. Mission planners would need to consider not just where the rings are today, but where they'll be years or decades into the future. The development of space elevators or other Earth-to-orbit transportation systems would face additional complexity. Any tether or structure would need to pass through the ring plane, requiring either gaps in the rings or incredibly robust construction to withstand constant micro-impacts. This might drive innovation in self-healing materials or distributed structural systems. In the end, Earth's rings would transform space exploration from a relatively straightforward engineering challenge into something approaching three-dimensional chess. Every mission would require unprecedented precision, international coordination, and technological innovation, but they would also provide inspiration, resources, and scientific opportunities that could ultimately make humanity a more capable spacefaring species. The rings would serve as both barrier and bridge, making our first steps into space more difficult, while potentially providing the resources and motivation for much grander ventures among the stars. And so we arrive at the final chapter of our celestial thought experiment, a gentle conclusion to our journey through a world adorned with rings. We've wandered through the physics of orbital mechanics and the poetry of perpetual twilight, explored the profound implications for life on Earth and the transformative effects on human civilization. We've witnessed how these majestic arcs of light and shadow might reshape everything from migration patterns to mythology, from tidal forces to technological innovation. But perhaps the most remarkable aspect of imagining Earth with rings isn't the science itself, but what it reveals about our relationship with the cosmos and our place within it. Throughout our exploration, we've seen how rings would fundamentally alter the human experience of existence. Every sunrise and sunset would be transformed into a cosmic performance, with ring shadows dancing across landscapes and ring shine illuminating the night. Children would grow up pointing not just to the moon and stars, but to the great arcs spanning their sky, learning navigation from celestial landmarks that never moved, telling time by the progression of Earth's shadow across the ring plane. The very rhythm of life would be different, synchronized not just to the sun and seasons, but to the eternal dance of light and shadow cast by our planetary ornaments. The cultural implications stretch far beyond mere aesthetics. In our imagined ringed Earth, human civilization would have developed entirely different mythologies, navigation systems, and scientific understanding. The rings would serve as humanity's first and most obvious evidence of gravitational forces at work, potentially accelerating our understanding of physics by centuries. Ancient astronomers wouldn't need telescopes to observe the complex dance of celestial mechanics. They would witness it overhead every single day. The very concept of orbital motion would be intuitive rather than revolutionary, learned by children watching shepherd moons trace their predictable paths along the ring edges. But rings would also present profound challenges that might have shaped human development in unexpected ways. The debris that occasionally falls from rings would create a constant, low-level hazard, perhaps leading to the development of more robust architecture and emergency response systems. The interference with radio communications might have pushed us toward different technologies entirely, possibly accelerating the development of fiber optic networks or alternative communication methods. Space exploration would follow radically different trajectories, with early missions focused on ring maintenance and resource extraction rather than lunar landings. The environmental effects we've discussed, particularly the climate impacts of ring shadows and reflected light, would create a world with different weather patterns, seasonal variations, and ecological adaptations. Ecosystems would evolve around the predictable shadow cycles, with some regions experiencing enhanced growing seasons due to scattered ring light, while others adapted to the cooler temperatures of frequent ring shadows. These climate variations would influence everything from agricultural development to human settlement patterns, creating a fundamentally different geographical distribution of civilizations. From a technological perspective, the presence of rings would represent both obstacle and opportunity. While satellite deployment would become more complex and expensive, requiring careful navigation through ring gaps and protection from ring debris, the rings themselves would offer unprecedented opportunities for resource extraction and scientific study. The materials contained within planetary rings, particularly if Earth's rings formed from captured asteroids, rich in rare earth elements or water ice, could provide the foundation for a space-based economy that developed much earlier in human history. The psychological and philosophical impacts might prove even more profound. Living under a sky dominated by such obvious evidence of cosmic forces would likely produce a more space-aware civilization from the very beginning. The concept of humanity as part of a larger cosmic system would be viscerally obvious to every person who ever looked up. This might lead to earlier development of environmental consciousness, greater international cooperation driven by shared celestial landmarks, or perhaps entirely different philosophical and religious frameworks centered around the cosmic dance visible overhead. Consider how different our scientific development might have been. Kepler's laws of planetary motion would be observable in miniature every night, as small moons shepherded ring particles in their endless orbits. The concept of tidal forces would be understood not as an abstract gravitational effect, but as the visible mechanism shaping the rings themselves. Newton's insights about universal gravitation might have come centuries earlier, prompted by careful observation of ring dynamics rather than falling apples. The economic implications extend far beyond space-based resource extraction. Earth's rings would create entirely new industries, from ring-watching tourism to specialized insurance markets covering ringfall damage. Weather prediction would become far more complex, requiring models that account for ring shadow effects and the thermal dynamics of ring-planet interactions. Agriculture would develop different techniques optimized for the unique light and shadow patterns created by ring geometry. Even our concept of beauty in art would be transformed. Imagine the paintings, sculptures, and architectural designs inspired by the daily spectacle of ring-lit skies. Music might develop different rhythmic patterns based on the visible periodicities of ring features. Literature would be filled with metaphors drawn from ring dynamics, shepherd moons, and the eternal dance of light and shadow overhead. The very language we use to describe time, change, and permanence might be fundamentally different, informed by the constant presence of these celestial timepieces. Yet for all these dramatic changes, perhaps the most profound effect would be on human unity and perspective. Every person on Earth would share the same magnificent sky, the same celestial landmarks, the same cosmic calendar written in light across the heavens. Political boundaries would seem arbitrary beneath a sky that clearly demonstrated Earth's fundamental unity as a single planet adorned with a single ring system. The overview effect that astronauts describe, that sense of Earth as a unified, fragile oasis in space, might be a common human experience rather than the privilege of a few space travelers. The rings would serve as a constant reminder of our planet's dynamic nature and our place within larger cosmic processes. Unlike the distant stars or even our moon, which can seem separate from Earth, planetary rings would be obviously, undeniably, part of our world. This might foster a more sophisticated understanding of Earth systems and our role within them, potentially leading to better environmental stewardship and more sustainable development practices. As we conclude this thought experiment, it's worth reflecting on what the exercise itself reveals about human nature and our relationship with the cosmos. Our ability to imagine such detailed scenarios, to explore their implications across multiple domains of human experience, speaks to our fundamental curiosity about our place in the universe. We are creatures who look up at the sky and wonder, what if? Who can envision alternate realities and explore their implications with both scientific rigor and poetic imagination. In many ways, Earth already has its own kind of rings, invisible but no less real. The aurora oval traces magnetic field lines around our planet like a ring of light. Our artificial satellites create technological rings of communication and observation. The debris fields we've created in orbit form unintentional rings of human-made material. Even our understanding of Earth systems, from ocean currents to atmospheric circulation patterns, reveals ring-like structures and flows that connect our planet in great circular patterns. Perhaps the most beautiful aspect of imagining Earth with rings is how it highlights the extraordinary nature of our actual world. Our clear, unobstructed view of the stars, our ability to launch spacecraft without navigating through debris fields, our direct relationship with solar radiation, unfiltered by ring shadows. These are not mundane features of a boring planet, but remarkable characteristics that have enabled the specific forms of life and consciousness that we represent. The thought experiment of Earth with rings ultimately returns us to a deeper appreciation of Earth without them. Our planet's elegant simplicity, its clear skies and unimpeded horizons, its delicate balance of atmospheric, oceanic, and geological systems. These create the precise conditions that allowed not just life to emerge, but intelligent life capable of wondering about rings in the first place. In the end, whether Earth has rings or not. We remain cosmic creatures living on a cosmic stage, participants in the ongoing story of a universe that grows ever more complex and beautiful as our understanding deepens. Our ability to imagine ringed Earths and explore their implications is itself a kind of magic, a demonstration of consciousness engaging with cosmos, mind contemplating the infinite dance of matter and energy that surrounds us. Tonight, as you look up at our actual sky with its familiar patterns of stars and moon, perhaps you'll carry with you some sense of the alternative worlds we've explored together. The rings may exist only in imagination, but the wonder they inspire, the questions they raise, and the broader perspective they provide on our place in the cosmos, these are real and lasting gifts of human curiosity and creativity. As we reach the end of our journey through this cosmic thought experiment, it becomes clear that the question of what if Earth had rings is far more than mere speculation. It's a profound exploration of how the smallest changes in our cosmic neighbourhood could fundamentally reshape everything we know about life, civilization, and our place in the universe. The existence of Earth's rings would have created a world where humanity developed with an entirely different relationship to the cosmos. From our earliest ancestors gazing up at the night sky, those magnificent arcs of light would have been constant companions, shaping not just our understanding of astronomy, but our very conception of time, space, and divine order. The rings would have served as humanity's first calendar, our first compass, and our first glimpse into the mechanical precision of celestial motion. Consider how different our mythologies might have been. Instead of seeing constellations as distant, unchanging patterns, ancient civilizations would have witnessed the dynamic dance of ring particles, the subtle shifts in brightness and colour, the way shadows moved across the Earth's surface with predictable precision. These observations would have accelerated our understanding of orbital mechanics by centuries, perhaps millennia. The scientific revolution might have begun not with Galileo's telescope pointing toward distant planets, but with careful observations of the rings' behaviour directly overhead. The environmental implications we've explored reveal just how interconnected Earth's systems truly are. The dramatic climate variations caused by ring shadows would have driven evolution down radically different paths. Species would have developed remarkable adaptations to survive in a world of extreme seasonal contrasts, where entire regions might experience months of perpetual twilight. The resulting biodiversity might have been even more spectacular than what we see today, with organisms perfectly tuned to exploit these unique environmental niches. Ocean currents, those great conveyor belts of heat and nutrients that regulate our planet's temperature, would have followed entirely different patterns. The altered wind systems caused by uneven heating would have created new upwelling zones, different migration routes for marine life, and perhaps even alternative locations for the emergence of complex ecosystems. Coral reefs might have thrived in waters that today are too cold or turbulent, while other regions that currently teem with life might have become biological deserts. The technological trajectory of human civilization would have been fundamentally altered by the presence of rings. Our ancestors would have been forced to become sophisticated astronomers and mathematicians much earlier in history, developing precise calculations to predict ring behaviour and its effects on weather patterns. Agriculture would have evolved unique strategies to cope with the complex growing seasons created by ring shadows, leading to innovations in crop selection, irrigation, and food storage that we can barely imagine. Space exploration would have taken on an entirely different character. Rather than looking up at empty space as a vast, uninhabited void, humanity would have grown up with the knowledge that space immediately above us was filled with accessible material. The psychological barrier to space travel might have been much lower, as the rings would have provided a natural stepping stone to the cosmos beyond. Our first space missions might have been mining expeditions to the rings, rather than tentative probes to distant worlds. The development of space-based industry would have been accelerated by centuries. With abundant raw materials orbiting overhead, humanity might have established permanent space habitats much earlier, using ring particles as both construction material and radiation shielding. The economic implications are staggering to consider. Nations might have competed not just for terrestrial resources, but for access to specific ring segments, leading to entirely new forms of international law and cooperation. From a cultural perspective, the rings would have created a truly unified human experience in a way that few other phenomena could match. Unlike the Sun, which appears different at various latitudes, or the stars, which change with the seasons, the rings would have been visible to virtually every human on Earth throughout history. This shared celestial heritage might have fostered a stronger sense of global identity, a recognition that all humans lived beneath the same cosmic architecture. Religious and philosophical traditions would have developed along markedly different lines. The rings' obvious artificiality, their perfect geometric precision, would have raised profound questions about the nature of creation and humanity's purpose in the universe. Some cultures might have viewed them as divine gifts, others as cosmic prisons, but all would have grappled with their meaning in ways that would have enriched human thought immeasurably. The rings would have also provided a constant reminder of the dynamic nature of the cosmos. Unlike the seemingly unchanging stars, the rings would have been obviously active, with visible changes occurring over human timescales. This might have led to an earlier understanding that the universe itself is not static, but constantly evolving, preparing humanity for later discoveries about stellar evolution, galactic motion, and cosmic expansion. Perhaps most intriguingly, the presence of rings would have fundamentally altered humanity's perception of Earth's place in the solar system. Rather than seeing our planet as unique and isolated, we would have grown up knowing that we inhabited a world that was, in some ways, similar to the giant planets in the outer solar system. This might have fostered a more nuanced understanding of planetary formation and evolution, and perhaps even influenced our search for habitable worlds around other stars. The scientific opportunities presented by Earth's rings would have been extraordinary. Planetary science would have advanced much more rapidly, driven by the ability to study ring dynamics up close. Our understanding of tidal forces, gravitational resonances, and the behaviour of particulate matter in space would be centuries ahead of where it stands today. These insights would have applications far beyond astronomy, influencing everything from materials science to fluid dynamics. The environmental monitoring capabilities that rings would have provided cannot be overstated. The way ring particles interact with Earth's magnetic field and atmosphere would have given us unprecedented insight into space weather, solar activity, and the complex interactions between our planet and the solar wind. This knowledge would have been invaluable for understanding climate change, predicting solar storms, and protecting both ground-based and space-based technology. As we contemplate this alternative Earth, we're reminded of the delicate balance that characterizes our actual world. The absence of rings is not a cosmic oversight, but rather the result of specific conditions and timing that have shaped our planet's evolution. The Moon's presence, the particular history of impacts in our region of space, and the gravitational dynamics of our solar system have all conspired to give us the Earth we know today. This thought experiment also highlights the incredible complexity of planetary systems. Every feature of a world, from its magnetic field to its ring system, influences every other aspect of its development. The absence or presence of rings would have cascaded through every system on Earth, creating a world that might be recognizable in its basic structure, but alien in its details. The exercise of imagining Earth with rings ultimately returns us to a deeper appreciation of our actual world. The clear, unobstructed skies that allow us to see distant galaxies, the stable climate that has permitted the rise of complex life, the accessible space environment that has made our first steps into the cosmos possible, all of these features of our Earth are extraordinary gifts that we often take for granted. Yet this exploration also fills us with wonder at the infinite possibilities that exist within the cosmos. Somewhere among the thousands of exoplanets we've discovered, there are likely worlds with ring systems far more spectacular than anything we've imagined. There may be planets where rings create aurora displays of unimaginable beauty, where the interplay of multiple ring systems creates kaleidoscopic patterns in the sky, where life has evolved in ways we can barely conceive. The question of what if Earth had rings is ultimately a question about the nature of change and possibility. It reminds us that our world, as perfect as it seems to us, is just one of countless possible worlds that could have emerged from the cosmic dance of gravity, chemistry, and time. It encourages us to look up at our clear skies not with disappointment at what's absent, but with gratitude for the unique beauty and opportunities that our particular cosmic circumstances have provided. In the end, whether Earth has rings or not, we remain part of an extraordinary universe filled with wonders beyond our imagination. The rings of Saturn, the storms of Jupiter, the ice geysers of Enceladus, all of these marvels exist within our cosmic neighbourhood, waiting to be explored and understood. Our ringless Earth has given us the perfect platform from which to discover and appreciate these distant wonders, and perhaps that is the greatest gift of all. As we continue to explore the cosmos, we carry with us the curiosity and wonder that make us human. The same qualities that led us to imagine Earth with rings will guide us as we venture out to worlds where such rings actually exist, where we can witness firsthand the cosmic processes that we've only dreamed about. In that sense, the question of what if Earth had rings is not just about the past or present, but about the future. A future where humanity will walk beneath alien skies and witness wonders that will make even the most spectacular ring system seem commonplace. As we reach the end of our cosmic journey through this hypothetical ringed Earth, it becomes clear that such a transformation would fundamentally reshape every aspect of our existence. The presence of rings would create a planet that is simultaneously more beautiful and more challenging, more inspiring and more complex than the world we know today. The environmental implications alone would be staggering. Imagine entire ecosystems evolving in response to the ever-changing patterns of light and shadow cast by our celestial rings. Plants might develop unique adaptations to thrive in the shifting illumination, while animals could evolve migration patterns synchronized with the ring's seasonal appearances. The very rhythm of life on Earth would beat to a different drum, one conducted by the graceful dance of countless ice and rock particles orbiting high above our heads. From a technological standpoint, humanity would have developed along entirely different trajectories. Our ancestors might have become master astronomers out of necessity, learning to navigate by ring positions rather than stars. The development of space technology would likely have accelerated, driven by both the obstacles and opportunities presented by our orbital companions. We might have achieved space-based civilizations centuries earlier, using the rings as stepping stones to the cosmos. The cultural and psychological impact cannot be overstated. Every human civilization would have grown up under the constant reminder of cosmic forces at work. Our art, literature, and philosophy would be infused with themes of cycles, celestial mechanics, and our place within larger cosmic systems. Religious and spiritual beliefs would likely center around the rings as symbols of eternity, divine presence, or the interconnectedness of all things. Perhaps most intriguingly, a ringed Earth would serve as a daily reminder of the dynamic nature of our planet. Unlike our current stable world, where geological changes occur over timescales beyond human perception, ring dynamics would provide visible proof that our planet is part of an active, ever-changing cosmic system. This awareness might have fostered a deeper environmental consciousness and a more profound understanding of planetary stewardship. The scientific implications extend far beyond our own world. Living with rings would have given us unprecedented insights into planetary formation, orbital mechanics, and the behaviour of particle systems in space. We would likely be decades or centuries ahead in our understanding of other ringed worlds in our solar system and beyond. The presence of rings might have accelerated our discovery of exoplanets and our comprehension of how planetary systems evolve. As we contemplate this alternative reality, we gain a renewed appreciation for the delicate balance that characterises our actual Earth. The absence of rings is not a deficiency, but rather one of the countless factors that have allowed life to flourish in the specific ways it has. Every aspect of our world, from the length of our days to the behaviour of our oceans, represents a unique solution to the cosmic puzzle of habitability. This thought experiment ultimately reminds us that Earth's current configuration is just one of countless possible worlds. By imagining alternatives, we develop a deeper understanding of the forces that shape planets and the incredible diversity of environments that might exist throughout the universe. In contemplating a ringed Earth, we not only explore the realm of possibility, but also cultivate a sense of wonder about the cosmos and our extraordinary place within it.